Hello, this is KeenanPark, and this is YLOC 7th grade worksheet lesson 16. So for our first problem, we have Jim, who has 38 bottles of water in 9 packs of X bottles and 1 pack that contains only 2 bottles. So what is the value of X? So to solve this problem, we can do write an equation. So we have the 38 bottles of water, and this is equal to the same as 9 packs of X bottles and another 2 bottles. So we have 9 packs of X bottles. So there's X bottles in these 9 packs, so we have 9 of them. So we multiply by 9. And then we add 2, because there's 1 pack that only has 2 bottles, so we're adding another 2 bottles. So we just add it. And now all we have to do is solve this equation. So we subtract 2 from both sides, and we end up these two 2's cancel out, and this 38 minus 2 becomes a 36. And that equals 9x. And all we have to do is divide both sides by 9 now to get our final answer. So 36 divided by 9 is 4, and these two 9's cancel out. So we end up with 4 equals x. So the value of x is 4, which gives us b. Alright. Next problem. We have number 2. How wide is the room, the length of which is 5 yards, and the perimeter is 16 yards? So let's try to understand this problem. I think the easiest way to start would be to draw it. So we have this rectangular room. I assume it's rectangular. Most rooms tend to be. And so we have this length of 5 yards. And we know the whole perimeter, all 4 sides of this, is equal to 16 yards. So then what is this width? We're trying to find this length right here, this width. So the perimeter is you add up all 16 yards. So we're going to call this missing side W because it stands for width. And for rectangles, the opposite sides have the same length. So this other side is W, and also this bottom side is 5 yards as well. I'll get rid of the yards because everything is in yards, so don't really need the unit. So we have all of these sides added together is equal to 16. So we can get an equation from that. So if we add up these sides, we get 5 plus W plus 5 plus W. So that ends up being 10 plus 2W. And that is equal to 16. And now, like the last problem, all we have to do is subtract to cancel because we want to isolate the variable. So we end up with 2W. 16 minus 10 is 6. And then we divide both sides by 2. And you end up with W equals 3. So our final answer is 3 yards. A. Alright. For our next problem, Jackie has 5 bottles of lemonade on her lemonade stand. In order to raise money for her dance club, she needs at least 100 bottles of lemonade. A pack of lemonade contains 12 bottles, so how many packs of lemonade does Jackie need to get her minimum number? Well, to do this, we can find how many packs of lemonade does she need at least. So we can do this using an inequality. So she already has 5 bottles, and she wants to be at least 100. So at least means we're greater than or equal to 100 bottles. And so that means her 5 bottles plus an additional, we don't know how many, X packs, and each X has 12 bottles. So this quantity, 5 plus X times 12, is greater than or equal to 100. And now we can find this inequality, we can solve for it. So like always, you can subtract 5 from both sides. So we get 12x. I'm just going to move the 12 to here because it's more standard that way to be in front of the variable, this coefficient. And we're going to have 95 here. And next, we can divide both sides like usual. So we get x is greater than or equal to 95 over 12. And now 95 over 12 is a fraction. It cannot be reduced to a whole number. So it's obviously not normal to be buying a fractional number of packs. So we're going to find the smallest whole number that's greater than this fraction. So one way of doing this is we can convert this to a mixed number. And so how many 12s can go into 95 at the most? Well, that will end up being 7 12s. 7 times 12 is 84. So end up with 7, and then 95 minus 84 is 11. So end up with 7 and 11 12s, which means x is greater than or equal to 7 and 11/12. And the smallest number that's greater than 7 and 11/12 is 8. Because 7 and 11/12, if you draw a number line, there's 7 here and there's 8 here. 7 and 11/12 would be about here, very close to 8. So 8 will be just over. So our final answer should be 8. Alright, and now for problem 4. We have 3 bikes and X cars in the body shop, and we want the greatest number of cars, but we want the total number of wheels to be less than 31. Same thing as before, we just write in inequality. 3 bikes has 2 wheels. Each one has 2 wheels. So we will multiply by 2. And X cars. Each car has 4 wheels. I assume the cars are all 4-wheel cars. And this we want to be less than 31. Coolio. So 3 times 2 is 6, so I'll just write that out here, simplify that a little bit. And now, like before, we just subtract. And you get 4x is less than 25, and then you divide by 4. And like before, we end up with a fraction. And just like before, we're going to convert this to a mixed number. So it'll be 6 and 1/4, because 4 goes into 25 6 times. That gets 24, and you're left with 1 left. So x is less than 6 and 1/4. If you want to draw a number line, 6 is right here, and 6 and 1/4 is right here. And 5 is about here. So the greatest number, which is less than this, so less, the greatest whole number would be 6. So we get 6. And if you want to plug it in, we can plug it in to see if that's correct. So 3 bikes, that's 6 wheels, plus 6 cars, or 6 cars, we found it's 6, and each of the 6 cars has 4 wheels, so we multiply and we get 24 wheels, and that's equal to 30. And 30 is indeed less than 31, so it seems that we have gotten a valid solution. Alrighty, Siobhan has 100 flowers, and how many bouquets of 7 flowers can she make? Well, let's divide. We want to divide these flowers into bouquets of 7, so we'll do 100 divided by 7. Let's do long division for this one. And so you do the standard long division practice. I hope you all know how to do long division. I'm going to subtract 28, because 7 goes into 30 4 times at the most. 7 times 4 is 28, so we get left with 2. So we have a remainder of 2. And so these remainders cannot be used, unfortunately, because we don't have enough of them. But these 14 bouquets have been completed, so she can make 14. Alright, the next problem, we have Tigran, sorry, I don't know how to pronounce that, wants to pay a bill of $28 with banknotes of $5. So what is the least number of banknotes he will need? Once again, we can divide using long division. And we end up with 5 with a remainder of 3. Now, this time the answer is not 5, because what is the least number he needs? Well, you can't pay with less money than what you need to pay. You need to pay with at least as much money, more money. More money if you don't have the exact amount of money. So he needs to pay a little bit more than 5 of these banknotes. So he will need to pay 6 banknotes. That's the smallest number that's more than 5. It's more than 5 and 3/5, in fact. Alright, hopefully that made sense. And moving on to the next problem. The cab driver charges a $5 fee, start fee, and $3 for every travel mile. And we're going to write an inequality for the greatest number of miles that the cab driver will drive for $30. So it's the same as all the other problems. It's just, in fact, this is easier because all we have to do is write the inequality. So let's think about it. We have $5 to start with, and then you add $3 for every mile. So this is the number of miles. Actually, I'll write this as m. That way it's easier to understand. And you can use any letter for a variable, generally. And then we're going to write an inequality. So what's the greatest number for $30? So the amount we spend has to be less than $30, in fact. Because if we want to travel more miles than we have $30 to pay for, then that wouldn't be right. So we have to do less than that. So end up with 5 plus 3m is less than or equal to 30. And don't be scared that these x's are there instead of m's. Like I said, you can use any number, and also the order doesn't matter because addition is commutative. So we end up with 3x plus 5 is less than or equal to 30. So it seems like the answer is A. Alrighty, and now we're going to solve for x. This is the same old. We're solving inequalities though instead. Alrighty, so like always, you want to isolate the variable. So I'm going to do these rather quickly, I think, and hopefully you can follow along. So we add 0.2 to both sides, and that ends up with 0.3x is greater than 1.2. And now we divide both sides by 0.3. And if you can't do that, you can try multiplying both sides by 10 and then dividing by 3. That also works. And then you'll end up with x is greater than 1.2 divided by 0.3 is 4. So x is greater than 4. Alright. For our next problem, we have 1/3 x plus 1/2 is greater than 1/6. Like before, we want to isolate the variable, subtract 1/2 from both sides. We end up with 1/3 x is greater than 1/6 minus 1/2 is negative 1/3. I simplified that very quickly. You can obviously use the common denominator to make this 3/6 and leave this as 2/6. That's also fine. Now we're going to divide both sides by 1/3, or actually multiply both sides by 3 might be a little easier to understand. I used the x as a times, so let's not do that. Alright, and then you end up with x is greater than negative 1. And that is our answer. Yes, that is our answer. X is greater than negative 1. For our next problem, let me move down. 1.4x plus 0.1 is less than 2.9. Like before, subtract 0.1 from both sides to isolate. 1.4x is less than 2.8. Divide both sides by 1.4. We end up with x is less than 2. Next problem, we're going to subtract 2 from both sides. And now this problem, upcoming in this problem, is going to be a little interesting thing, so tune in for that. Negative 1/2 x is less than, we end up with this equals negative 5/3. And now we're going to multiply both sides by 2. So we end up with negative x is less than negative 10 over 3. And now we're going to multiply both sides by negative 1, and we get x and 10 over 3. But the thing is, it's now x is greater than 10 over 3. You see, when you multiply by a negative number or you divide by a negative number in an inequality, you have to switch the direction of the center component. So it goes from less than to greater than. That's because if I have a number line, let's say this is 0, and I have some number, and I want x to be greater than this number, but if we flip it around, I want x to be less than this number, it's a negative number, and if we flip it around, well, the x that was like here, let's say, also should get flipped around, and so it should be greater than this number. So hopefully that makes sense. It just wants to be more extreme. So you also have to flip the sign from being less than to being greater than. Alright. For our next problem, an interesting inequality. We're trying to solve for x, but we actually don't have an x. So let's see if this is true at all. So we can actually just simplify this 0.4 minus 0.5, and we get negative 0.1. And by the way, I believe this is an error by the creator of this worksheet, but we will go along with it because we can learn something from this. And now we get negative 0.1 is greater than 3. Is negative 0.1 greater than 3? Well, it's not. It's a negative number. Negative numbers are always smaller than positive numbers. So that means this is not true. And so in fact, we can say that this is, there are no real solutions for x. In fact, there are no solutions at all. So we'll ignore that part for a sec. And we'll just say no solutions, because no matter what I put for x, it doesn't change the fact that this inequality will always be false. Alrighty, and for our last problem, we have 1/4 is greater than 1 plus x over 2. Like always, subtract 1 from both sides to isolate. We get negative 3 over 4 is greater than x over 2. Multiply both sides by 2, and we get negative 3 over 2 is greater than x. And that is our final answer. If you want, you can switch it around. X is less than. When you switch things, you also have to switch their signs, or not their signs, but the direction of the inequality, of course. The pointy bit is pointing at x here, and the pointy bit is also pointing at x here. And so we have x is less than negative 3 over 2, or negative 3 over 2 is greater than x. That's the end of this lesson. Thank you for listening, and goodbye.